Hello everyone, welcome back to my channel. In this video we are going to solve this type of question. We are going to solve this problem. Now the question says, a step down chopper has a resistive load of 15 ohms and an input voltage of 200 volts. When the chopper remains on, its voltage drop is 2.5 volts. The chopper frequency is 1 kilohertz. If the duty cycle is 50%, determine the average load voltage and current, the RMS output voltage and current, chopper frequency, the power output, the power input, and effective input resistance of the chopper. So how do we solve this? The first thing we are going to do is to draw the chopper circuit diagram. So when the switch is on mode, we have our output voltage here, right? This is our output voltage. Then our Vs will be equals to VL plus V output. The question says when the chopper remains on, its voltage drop is 2.5 volts. So we can have our Vs, our new Vs will be Vs minus the chopper voltage drop, which is 200 minus 2.5, which in turn give 197.5. So from this equation, right, we have VL equals to Vs minus V naught. So multiplying both sides by T on, we have VL T on equals to Vs minus V naught multiplied by dt. And of course, this is our new Vs. The Vs here is our new Vs, which is Vs minus VCH. So let me write it. We have VL T on is equals to Vs minus VCH minus V naught multiplied by dt. So when the switch is off, one minus dt. When the switch is off, there won't be any supply voltage, right? So this is what we have here. We have only this short circuit space here. So our VL plus V naught will be equal to 0, which gives VL is equal to minus V naught. And if you multiply both sides of the equation by T off, we have the absolute value. We are going to take the absolute value of this, right? So you have V naught 1 minus dt. So we have to equate this equation with this equation, right? So we have Vs minus VCH minus V naught multiplied by dt will be equals to V naught 1 minus d multiplied by t. Then we know, so t will cancel out t. So we have dvs minus dvch minus dv naught equals to v naught minus dv naught. So this can cancel out this. So we have v naught is equals to d vs minus vch, and of course v naught will be equals to, our duty cycle is 50% from the question, so we have 0.5, vs is 200 minus 2.5, that is the chopper's voltage drop. So v naught is 98.75 volts. So this is our average voltage. So to find the average current, I average, you see, I average is equals to V naught over R load. So we have 98.75 divided by 15. I average will be equals to 6.583 amps. So the next thing is to find our VRMS. The expression for VRMS is the square root of 1 over t integral of 0 to t on, we have Vs squared dt. So this gives Vs of course, if we take the square root of Vs squared, we have Vs. Then we have the square root of 1 over t. The integral of the t is t. Then we have limit from 0 to t on. So this gives Vs square root of t on over t. But don't forget, d is the same thing as t on over t. So we have Vs root d. So VRMS now, VRMS is the same thing as Vs root d. Don't forget our Vs, we said our Vs is the 200, which is Vs minus V chopper multiplied by root d. D is 0.5. So we have VRMS will be equals to 139.65 volts. And of course, our IRMS is the same thing as VRMS over R load, which gives 139.65 over 15. IRMS is equals to 9.3 amps. So the next thing we are going to do is to find the efficiency of the chopper. So the efficiency is P out over P in. So P out is equals to V squared RMS over R. So we have VRMS to be 139.654 all squared over R is 15. Then P out equals to 1300.2 watts. Then P in, same thing as Vs multiplied by I average, which is 200 times our I average is 6.583. So this gives 1316.6 watts. So efficiency now equals to P out is 1300.2 over 1316.6, and efficiency will be equals to, we have 0.9875 multiplied by 100%. So we have efficiency is 98.75%. So the next thing is to find our input and output power, which we found already. And then we move to the next question. The next question is to find the effective resistance of the chopper, right? So the effective resistance of the chopper is RL equals to Vs over I average. We have Vs to be 200 over I average is 6.583. So if we divide this, we have 30.4 ohms. So our RL is 30.4 ohms. Like the effective resistance of the chopper is 30.4 ohms. And we've come to the end of the question. Thank you.